My name is Gabriel. I'm the robotics PM, and with me today is Michał Sawicz, our engineer manager for Mir. How are you, Michał?
I'm very good, thank you. And actually, you're also RPM, not just robotics.
Robotics and Mir PM. I think I said that, but thank you for letting me know if I did it. Thank you for joining us, even though you you just correct me at the beginning. But we have met. We have been working together for 3 years now, right? Something like that. And I think that you have been Canonical for longer. Am I correct?
Yeah, just a bit longer. It's going to be the 12-year mark in September.
And that means that you have been involved in different projects throughout the whole lifetime of Canonical. Which has been the most, the one that you keep as closest to your heart, your favorite one?
Well, I would say I was quite involved with the Ubuntu Frame. That was something that I think a lot of us have spent, a bunch of time on. And well, the good thing is that I'm still on the project that was born with it, and we're using Frame is actually using the technology that was born from the phone. So it's not all we've not dropped it all. There's stuff that we are still using and developing.
Exactly. There was really a project for a community that got a lot of attention, and I think that is an opportunity for everybody that is joining us now in the chat as well. If you want to say thank you to Sawicz for all his time working at Canonical, this is the perfect time to do that. If you want to complain, you can also do that in the comments. And any questions that you have, please put it there in the comment. We're going to try to make this as dynamic as possible to try to interact with you as much as we can. So don't wait until the end to pose your questions. Just put them right now in the chat. And hello to everybody that is saying hi on the chat. And yes, if you want to work at Canonical, you can apply. We are hiring. So just go to Canonical Jobs, to the job page, and you will find, hopefully, your next great job here at the company. With that in mind, let's begin. Again, questions in the chat. Video will be available after the stream. And this is the agenda that we have prepared for you today. First of all, we're going to give you a quick overview. For those of you that don't know what is Ubuntu Frame, we'll give you an overview of that. We will let you know where is it used, and then we will let Michał take the lead and take us through this journey of different demos on how you can use Ubuntu Frame and how you can take out the most of this tool and all the new features that we have been putting together. And before we start, it's a tradition in our webinars to talk about what our amazing teams are doing here at Canonical. So please, Michał, can you tell us what the Mir team is cooking?
Okay, sure. So it is. Sorry, I get confused. So we are working on a number of extensions to Ubuntu Frame as apart from just doing things across the board for but one of the things that we recently did was with the move to the 2204 base, we have enabled NVIDIA support now, so we can use the NVIDIA graphics cards to drive IoT graphics from here as well.
And that is part of the work that the Mir team at Canonical does, as one of the many engineering teams that we have at Canonical. Thank you for that quick overview. And with that, let's jump directly to the topic. What is Ubuntu Frame? Let's say that you're building one of these many devices, that you're creating a smart home hub, a digital kiosk, a robot, or you're just embedding your graphic application into a device that has a display, that has a screen, or that even is projecting something, okay? So to build this, you probably are using your favorite toolkit. It could be Qt. And we say hi to everybody that is joining us from the Qt community, from the Flutter community as well, from the many other toolkits that we have out there. And obviously, you will be creating this graphic user interface using Ubuntu, Winky. And now that you have created your application, now you have to embed it on your final device, on that small footprint device that probably is headless, that is running always dedicated for this type of applications. So it has some resource constraints in that sense in order to be as light as possible. One example of those operating systems, it could be Ubuntu Core, and you're trying then to migrate your application and embed it to Ubuntu Core. And you will be presented basically with these two options. You start working with display servers and Windows managers to help you orchestrate the communication that you will see between your user graphic application and the kernel in the hardware. We're talking about the diagram on the left. Or you will directly try to deal with the drivers, with the input protocols, the security policies, and so on, to try to talk directly to the kernel yourself. Whatever is the case that you pick, you will eventually have to deal with more code to manage, more opportunities to find bugs in this process, more vulnerabilities in untried code or abandoned code, or if you fork things and you stop maintaining them, because we know that a lot of us, we do that. Basically with that, it's just we end up in this trap of spending less time on our application, our graphic application, or in our device. So with that in mind, Canonical, the Mir team, decided to create Ubuntu Frame to help you solve that issue. It makes the integration easier for embedded systems while giving you all the tools and functionalities that you need to deploy, but also your user to use your graphic application. Ubuntu Frame is a reliable, secure, all-in-one display server for embedded Linux devices with long-term support. It will sit between your application and the kernel, as you can see on the diagram. It will bundle all the communication protocols, all the input protocols, the security policies into a single kit, which then you can use to embed it to your device. Plus, it has many other tools that we will be discussing today that will help you manage your device on the field. With that in mind, I will now let Michał explain us how exactly Frame works.
All right. So Gabriel, Frame is what manages the input and output hardware. So as I described, these are privileged resources. You often don't want your target application, your end user application, to directly be talking to the kernel for those devices. So Frame is mediating that access together with the Snap system, so that your application, even if you take it from a different vendor, is secure, does not have unnecessary access to the system. It allows applications to communicate over the Wayland protocol to get input and provide output, right? So just like it would on a normal desktop. The app may also need access to the network or access to other resources, those you request through the Snap interface connections. Your app on the right hand will automatically be placed full screen and will be the only thing users see and can interact with. As long as your graphic application is using the Wayland protocol, you can integrate it easily with Ubuntu Frame. So besides keyboard and mouse input, Frame also automatically enables all the functionality that end users expect while interacting with digital displays. This includes a wide range of touch gestures like multi-finger support, swipe, zoom in and out, touch to focus, and more. All of these. We also do provide our own on-screen keyboard. So your application is as long as your application is written one of the major toolkits, all of those today support Wayland natively. So you can choose what's best for your team. Rather than what happens to work when you want to talk directly to the hardware. Frame abstracts that hardware for your application to use.
And with that in mind, thank you. And with that in mind, Luis, thank you for your question. Yes, the presentation and a lot of resources and different links are available right now on the description on the LinkedIn invite. You should all have access to that. It's good to keep getting people joining. And therefore, please go there, check the links, and you will have those extra resources available. Like I said, the recording will be also available, and therefore you will have all the information there as well. And yes, we can spend more time talking about all the great benefits of Ubuntu Frame, but instead, let me give you an example of a use of Frame in the wild. And I want to name this company, this Turkish company, Pudo. Great company that right now they are deploying 820 automated parcel machines. So basically, as you know, if you want, let's say, Amazon to deliver something into one of these lockers instead of a property, you can go later on to the locker and you will find your parcel. So that is what Voodoo is helping with, that last mile delivery. And they are in 7 major cities, helping more than 8.5 million people in the world. In Turkey. And with that, they're using Ubuntu Frame and Ubuntu Core together to power their application, to power this embedded system. Of course, while using Ubuntu Core, they will get other added features as over-the-air updates, secure boot, and so on. And the combination of these two is what bring Voodoo to realize that it was a great idea to deploy with Ubuntu Frame. You find other use cases of Ubuntu Frame there. You find medical health kiosk that, as you well know, they need to go through a lot of different standards in security, in quality as well, and also points of sales inside restaurants, food chains around Europe. So Ubuntu Frame has all these features and also is being used and tested on the field, which gives you that extra hand the moment that you're deploying your solution. But I think that we have talked too much, and it's time to see a journey on how you can use these great features. So back to you, Sawicz, for you to take us in this journey.
Okay, thank you, Gabriel. So now that you know more about Frame, its purpose and who is using it, let's see it in action. I'd recommend running the stream full screen, as there will be some detail that will be hard to see otherwise. First, I want to show you how to install Frame. It's maintained by the Mir team at Canonical as a snap and published on the Snapstone. So have a look at the Snapcraft info, as there are a handful of channels available. Stable, beta, etc. we call risks, and you probably know what they mean. 20 and 22 are tracks in which we maintain Frame based off of the respective Ubuntu releases. The idea being that if you deploy on Core 20, though you shouldn't today, you don't have to bring the 2204 stack to keep the footprint small while receiving maintenance updates. The focus of development is the 22 track, though, and our recommendation is to deploy on Ubuntu Core 22, choosing the corresponding track. That's what's happening in the background here. The latest track is Legacy, and we hope to remove it in time. Now we need a client application, so we'll try WP. I will skip a piece of that installation. So WP is a community-maintained snap of the WebKit-based embedded web engine, or rather WP WebKit Mir kiosk, with what's installing there now. It doesn't currently have the 22 track, but we're working with the community to make that happen there as well. The result is that the installation will take a while, as it needs to pull in the older 20 stack, but it will still work fine. This shows one advantage of the snap system, where the client applications are sandboxed from others, and Frame, as long as they use a common protocol to communicate, in this case Wayland, they will work fine together despite being built off of different stacks. And I will also skip the rest of the install here to kind of keep things going. So roughly here. So we'll use the snap set command to choose a nice web page for WP to display. And that's happening in the stream right now. Because we're running on Ubuntu desktop to showcase all this, we need to tell snapd, the daemon managing snaps, that we want WP to speak to Frame over the Wayland interface. We do this via the snap connect command. We also need to tell them to work as daemons and start and boot. All that happens automatically on Ubuntu Core, so those few commands, those recent commands, we didn't need on Ubuntu Core. A few seconds later, you'll see the gray gradient. That's Ubuntu Frame, and then the website rendered by WP. This would be the boot experience from now on. You can interact with the website, but there's nothing else. You can only follow links, but not go to a different page or application. This replaced the desktop we were running from, and there's nothing else that's accessible. You can see this as I did this in the background, but when I use snap set again to change to a different URL, WP automatically reloads to what the target is. Again, you're confined to what the page gives you. Let's go back to the desktop, as we'll be running the remainder of this session there to easier follow what's happening. To do this, I disabled the daemon mode on both Frame and WP. With snap list, you can see what got installed in the background. You can see that the Core 20 base was pulled in by WP. The Core 22 one was already there and is used by Frame. But there's a handful more snaps. I'll highlight two, Mesa 20 and 22. That's the graphics software stack, the user space drivers. By replacing those, you can support hardware that isn't supported by the open source graphics stacks, or the releases provided by Ubuntu LTS. And that's, for example, how we support NVIDIA. You could also support a completely different stack for maybe an embedded system. We'll leave all of the resources. I know this is a lot of information. We will leave all of the resources in the LinkedIn invite. So next, I will be talking about some client applications. We're now back at the desktop, and I ran the remainder of this demo using emulator mode, basically running Frame itself as an application within the desktop. For that, I need to set the Wayland display variable to set to something other than the desktop itself. As mentioned, Frame is agnostic to your application's toolkit. If it supports Wayland, it will work on Frame. As a backup, we also have compatibility layers for X11 apps and even Windows, and even those from Windows. So here are a couple more clients. We've packaged a number of apps that fit the kiosk use case. I'll show you Kodi, the venerable media center, and ScanVM, something that you could build a retro gaming rig with. We'll skip the installs here too. After installation, we're using some helper scripts to connect some interfaces. In a real-world deployment, these will either be auto-connected globally in your custom image, or maybe in your own enterprise snap store. This ensures that we only allow access to those resources that are necessary for the application to work. Ultimately, you as the operator of the device have control. We'll run Frame now, and I'll ask it to have a window size that will be easy to work with in this setup. Because we set up the environment before, Frame listens on that socket, and when I run Kodi itself, that gets nested within Frame. It behaves exactly like you'd expect it to. Video acceleration is also supported, if enabled by the client and the graphical stack. Frame itself isn't involved in this particular case. And here's ScanVM with a handful of retro games bundled. Again, things just work as you'd expect them to. You could build that into a wooden case with a retro screen and a joystick, and you have an instant retro arcade game. It uses the SDL framework, which has native Wayland support, so it integrates great. And this is it on the client. So let's skip to the next one. And this is going to be the OSK for things that require keyboard input. We provide an on-screen keyboard snap. To enable it, just install Ubuntu Frame OSK from the Snap Store. Again, you have a choice of Ubuntu LTS bases, so we'll choose 22 as in the previous cases. In an Ubuntu core deployment, the installation would be it. Whenever the client application requests text input, the keyboard will pop up. In the simulator environment, I need to run it explicitly, but we'll start with the interface connections. So once those interfaces are connected, let's start Frame, and then Ubuntu Frame OSK itself. It speaks to Frame over the Wayland socket as any other client, but it is privileged to use some additional features. You can see it pop up as it starts up. I will run a text editor now, and it will do, but I'll go for the pre-installed GNOME one. It isn't even a snap. Again, as long as it speaks Wayland, it's fine. The OSK pops up, and Frame resizes the app away. You can type as you'd expect. I promise it's less awkward with a touch screen. There's also an emoji keyboard, of course. You can choose your own set of keyboard layouts to be surfaced, and this is going to be the next piece of that demo. This way you can tune your device to your target audience. You can use the Ubuntu Frame OSK.list layouts command to see what's available. Then use snapset to make a selection, separate multiple layouts with a command. They will be user selectable after that. This would restart the keyboard if running as a daemon. In this case, we'll run it again ourselves. Since we left US as the first layout, we can type as before. Uppercase characters, symbols, they are all available where you expect them. The globe icon, however, hides the other layout we wanted. I apologize as I type something in a script I don't know at all. I believe this says hot water now. I will now run WP again, but use a page that will allow me to show the text input. Let's just go to Mozilla's reference page for the HTML input element and run WP. You can see the keyboard goes away as there isn't a text field focused. When I click on the input field, again, the OSK pops up and resizes the web view away so we can access all of the app's content. And that's all in this section. So now let's get into how we can help users when things go wrong. I already have Frame running, and I've used another game we've packaged up, a mini golf game by the name Never Putt. We maintain the Ubuntu Frame VNC snap, again using the 20 and 22 tracks, so let's install the newer one in another terminal to speed things up. The VNC server communicates with Frame over Wayland. So like OSK, it's separated away. All the same applies. Connecting the Wayland socket and daemon mode are done automatically on Ubuntu Core, but here we'll run it by hand. While that is installing, I'll start the game. Sorry for the rendering speed. Apparently the virtual machine that I was running this on isn't very good at graphics. So let's start the server. Let's run the server now, and we need a client. I use the stock GNOME Connections app. Basically, any relatively current VNC client will do. We did identify that the internal macOS client is using a very old version of the protocol, and that is not supported. The server uses GPU acceleration where possible, so should be quite resource effective. I'll start the client pointing at localhost. Because VNC authentication and encryption is notoriously incompatible, we've chosen to only allow localhost access. And it's the operator's task to set up network access in whatever ways appropriate. SSH and VPN are the obvious candidates. We can now play the game remotely. I didn't do very well though. This is a very heavy example for this use case. Basically, every frame has to be pushed through whole, and you can see the virtual machine isn't coping that well. It's much better when it runs on hardware and is perfectly usable across the network for assisting users of your kiosk, for example. We had good messages, good words back from customers for whom this is solving real problems. And let's stop watching me fail at this game. So how do you know that when users need help, or how do they know how they can access any help from you as the operator of the device? So one of the, it's a really tiny feature, but we believe it's unique and often overlooked. So let's run our kiosk app. You know the drill by now: setting up the environment, choosing a URL as we use WP, starting frame, and starting the web view. By the way, the gray background is configurable, and we're working on it actually being the boot splash rather than a custom background. So what happens when your app stops working? Yes, the gray background. Though better than the blue screen of death, it's still not very helpful. So enter the diagnostic feature, and to use it, we'll install a tiny utility, Frame Diagnostic. It's not meant to be used in production, so it's only available from the Edge channel. Instead, you should integrate your own app as a system service directly. Again, all of the resources will be available and are available on the event. So go there to find out about anything I'm talking about. So let's start our client up again. Now we'll tell Frame Diagnostic something and start our application, simulating it crashing and not starting up again. This wouldn't normally happen, as the daemon mode tries to restart every component a number of times. After a configurable timeout, Frame itself will display the message given to Frame Diagnostic. It's part of the compositor, so things would need to go really wrong for that not to display. You could have a good service that sets up an initial message, and maybe a watchdog kind of service that amends it when it notices things going wrong. But maybe you displayed a kind of under maintenance message if your watchdog sent an alert to your monitoring system as the message on screen updates live. If we look at the Frame Diagnostic tool, you can see it's quite simplistic, just writing the message given as arguments to a file. That file actually lives in Frame's sandbox and is shared with the diagnostic tool via the content interface connection. Your own application would integrate the same way. You can also change some properties of the diagnostic screen, like the colors used. If the client app resumes, the timer is reset and the message won't show up again until the client goes away for the configured file. Last but not least, I like to showcase you how we can drive and manage multiple displays from a single device, optimizing your hardware use. Today, this is primarily targeted at digital signage. You can have multiple touchscreens, for example, but we're thinking of extending things to the multi-seat use case. Having run Frame already, it populated the display configuration with the details of the outputs it's running on. You can use the snap get command to see what Frame knows about them. For this part, I cleared up since we're now running in the emulator mode and not on the virtual hardware directly. For that, I can set the display variable to null, and the next time the daemon starts, it will populate it again with the defaults. I'll also remove the local copy frame made for the emulator mode. I will now run Frame, telling it to act as if there are 3 different displays connected to it. And then run our Frame WP. You will see that the defaults for displays of different sizes are not particularly useful. Frame puts them all at X and Y 0 in the virtual space, so they all display parts of the same application. Let me arrange the displays in the order I set them up. You can now see we have 3 displays, 1 landscape, 1 portrait, and the middle one twice as tall. there's really no meaningful way to display the same content on them. Frame places the app on the first display and outputs the same viewing to the remaining displays cropped to the resolutions. The app can request to be drawn on another display, and Frame will respect that request. So if you control your application, you can use that approach. Let's run another app and see how that affects things. I'll use Kodi again. The app is simply overlaid on the first display. That is a fine default for the common case where you want to display the same content on multiple uniform screens. Beyond that, there's really not much we can do other than to give the operator control of it all. So Frame populates its configuration with another common display setup side by side, and you can switch to it by changing the content of the display layout config file. And when run as a daemon, use snapset instead. The second and third display have nothing to show now. If I stop Kodi, we'll be back to WP. I've prepared a slightly modified display configuration that I will show you now. Frame can configure multiple layouts to switch between atomically. This allows you to set the displays just right and stay within the constraints of those known good configurations, rather than replacing the configuration hole. The default layout is unchanged. I've added a couple options to the side-by-side layout, though. These tell Frame to always place the listed apps on the displays they're associated with. I've used snap names here, which are the most reliable, but you can use surface titles as well, if you're certain those are stable. The reverse layout is just that. It swaps WP with Kodi. You'd use snapset, again, to tell the daemon the desired display configuration, but in this case, we'll just put it into the file directly. The changes are applied live. If I now run Kodi, it will get placed on the third display, even if it requested a different one. This lets the operator retain control, even when using apps from other vendors. If I tell Frame to switch to the reverse layout, it just swaps the apps with as little redraw as possible. If I go to the default layout, you'll see the view you're already familiar with. You could use this feature to round robin a menu page between displays, for example, without having to add that behavior to your application. There's one more common way to use multiple displays, and that is a display wall, using multiple displays as a single bigger one. You do this by adding a group value to the displays you want to put together. Frame will then treat the whole group as a single display, the size of the whole group. You still need to configure the placement of them in the virtual space, as we don't want to make assumptions, and you can take, for example, bezels into account this way. Another config here is single, which disables all but the first display. They would get called to power down, so this could be a night mode, for example, where you only display some information on one of the screens. I'll add those two layouts to the display file and switch to the wall layout. You will see, even in this weird configuration, Frame stretched Kodi to span the two screens. Yes, we've lost part of the contents, but that was our choice. You can even interact with it, though that is unlikely to be useful in the real world. I'll now switch to a single layout and everything will be put back. If I left Kodi in the second and third displays, it would just stay there until the displays are turned on again. That is the end of my demos. Thank you very much for listening, and I hope I've piqued your interest. Let us know if you would like to know more, or if you think there's a feature missing. I will give you back to Gabriel.
Thank you for sharing all of those demos together. It's the first time for me as well that we can see all of those demos put one together after the other, telling us this great story of how Frame can help us. And we have been getting some questions, Sawicz. So before we move on, I think it's a good time to go and look at those questions. One of those that we were getting was regarding the OSKs. Are other OSKs available? Do we need, and what do we need to do to support another OSK if that is possible?
So yes, if you package your OSK as a snap, that would be preferable. But basically, the OSK software needs to support Wayland and the right interfaces, the right Wayland extensions to be able to interact with the system. We've based our OSK off of Squeakboard, but if you bring another one that fits those constraints, then yes, that's no problem.
Perfect. That is wonderful. Thank you for everybody that keeps joining the webinar. Question regarding the client application. We also got one about what are the requirements for client applications to work on Frame?
So as we discussed before, this is as long as it's running Wayland, or is ultimately the snap needs to speak to Frame over the Wayland protocol. I mentioned that we have compatibility layers either for X11 apps or even for Windows ones. So we then actually bundle the compatibility layer with the app, so that the only thing that the application speaks outside of itself is Wayland for security reasons. We don't want to expose X11 outside of the snap, so that we keep the security of what we've designed.
Perfect. I also see one in the chat with audio. If you have multiple devices, imagine that you're having a fleet of devices running core, a fleet of digital kiosk. There's a way to have a diagnostic of all of them, like some kind of MDM or something that to manage multiple devices. So I would like to first break this down into a perspective of Ubuntu Frame first. So how would you use Ubuntu Frame, let's say the diagnostic tool, when you have so many different devices?
So the primary idea behind the diagnostic tool is for it to be run in the background, and when things go wrong, you display that screen. As long as you have control of your application, you can just display that message within your app, right? That's as long as your application is running. To manage the hundreds of devices, that's something that Frame is just one part of that story, right? And you just want to manage the whole Ubuntu core fleet of devices, and we have some solutions for that. We are working on some others that we will be talking about when they become live.
I think that also for context, I don't want to take this topic into just Ubuntu core, but can you explain to us maybe an example? You also did through the presentation, but maybe you can repeat how Ubuntu core can help you. How can Ubuntu core detect that application is having an issue?
So in the case, the diagnostic just decides that the application is having an issue because it stopped, right? Whenever Frame doesn't have a client that to display, it will start running a clock, and after a configurable timeout, it will show that diagnostic. The idea here is that you have built your system in a way where maybe your, as I mentioned before, maybe on boot the diagnostic message is set to something pre-configured, but then as your application, as your system is running, maybe it updates, notices that something's going wrong. That is out of scope for Frame itself, but your software can do that detection and drop the right message into the diagnostic file. When the application stops working, you get it on screen. Even like the only thing running on that system is at that point Frame, but still it will display that screen to you.
Perfect. So it's like a layer approach. First, we can take it into the device. The tool of diagnostic will allow us to put a message per device when something fails. Later on, using the remote access, we will be able to check in if, for instance, we get the call of a customer telling us, hey, your kiosk right now is not working, it's displaying me this error, and we can log in remotely using the demo feature, right?
Right. So for the remote assistance bit is also going to be most useful when your application is working. Like this is probably more again useful where you have kind of maybe a chat system within your application. You ask for help, and then at some point somebody joins in and listens in. In the case when things go wrong, there you have to touch the device, maybe over SSH or whatever else management system you have set up on the device.
Perfect. I think right now that we can just go back to my screen, and I know that there's a lot of information that we just shared with all of you, and I think that like we were saying right now in the event description, you will have different links, and I believe that the best place for anyone that is new to all this field is the developer guide of how to embed an IoT graphic applications with Ubuntu Frame. It will take you through a lot of the steps that Michał was showing you, for instance, how to do that in your desktop environment, how to emulate, how your final screen is going to be looking at. Therefore, you can just follow this more than a tutorial in order for you to get a feeling and get you started in that journey. Okay? So with that, we get to the end of this webinar. Is there any last minute questions that you would like to ask? Thank you for everybody that has come and say hi from Paris, New York, from Turkey, Nigeria, and thank you for all the community. Please do remember the Mir team is already your team. And therefore, we are really happy to see you here. And we're looking forward, like Michał was saying, for you to share your feedback, for you to share your comments and so on. I do get through the other channel two different questions as well. One really quick is about using multiple display support. How many displays are supported at the moment?
So there isn't an internal limit from Frame, right? So as much as the hardware will let us. So one of the great one of the things that we're also working on right now is supporting hybrid setups. So there is one of the targets that we are thinking of for this is there are some NAC devices that have an Intel card and also a dedicated NVIDIA card. They have like 7 outputs in total, and you should be able to drive all 7 of those from a single NAC device. Again, the limit is in the resources of the hardware and not something that we impose.
Yes, that's great. One last question, waiting as well for the chat. Last one chance for everybody to put their questions. Talking about the graphics core 22, why extract graphical support from the Ubuntu Frame snap? I hope I got this question correctly. Sorry if I didn't.
Yeah, I think I know what this is. So normally with snaps, what happens is the snap will include the graphics user space for within itself. The problem with that is that first you, depending on what base your snap is built from. So we usually build from an Ubuntu base, but you take that snap into a different system, and it may not be compatible with that system. Maybe again, the NVIDIA use case is something that we were interested in with this, or embedded boards. Many embedded boards have custom graphics processors units, and they need firmware. They need a graphics stack that is directly tailored to that single board. So this was a way for us to support those devices, and also. One other use case is actually using like newer stacks. So depending on your hardware, maybe you're a gamer and wants to use a newer Mesa stack so that it best supports your GPU. And this would also allow this, right? So we default to the stable version of Mesa of the open source drivers found in Ubuntu, but you can replace that with a version that suits your use case best.
Really useful. Michał, thank you again for putting those demos together. Thank you for your time. Thank you, everybody that joined today. And I also want to thank to our team. You don't see them, but they are here helping us. Thank you, Felicia. Thank you, Anastasia. Thank you, Lisi, Hasmik, Ahmed, and everybody that helped us reach out to you today. Have a great day, and thank you for coming. Bye.
Thank you all. Bye-bye.